I will still wait 1 or 2 minutes just for later arrivals, and then we will start. Okay, folks? So, hello everyone. I hope you hear me loud and clear. Welcome to the Lisp working group in this IETF 112. We are a couple of minutes late, but was a little bit on purpose to wait a little bit. In the meantime, you got more familiar with the node well that applies here. The very short summary is that whatever noise you do during this meeting is a contribution to the IETF. However, there is also another little piece of not well that is important to detail is the fact that we have a code of conduct detailed in RFC 7154. Now, Lisp, I think that we behave, okay, and this is important. It's important to respect each one another, and that we have discussion based on technical argument, not nothing else, okay? And we struggle to find global internet solution and in operational environments, and we contribute to the IETF. As I said in Lisp, I think we behave, okay? Unfortunately, it's not in each working group that is going that way, but it's important that the same behavior you have here, please spread it in the IETF, bring people to be reasonable and respectful, okay? As for the business at hand, this is the usual pointer. I'm Luigi. Joel Alpern is my co-chair, is also online. Padma, also online, is also our secretary. She will provide the minutes offline later on, as usual. The usual links are here for the charter, the Jabber Room, audio stream, Mitico, and the agenda and slides. Okay. A little bit of an update. Since 111, there have been a few documents that have been pushed for publication, so are now in the hand of Alvaro, our responsible ID, which is also online. Okay, so we are making progress in a certain way. And I say in a certain way because if you see on your right-hand side, there is a lot of red, meaning that there are documents that are sitting there for a while. Okay. Now, the bottleneck is LispSec. Okay, is the last piece of work that is missing in order to unblock a lot of other documents, including, by the way, the Lisp introduction, okay, which has been updated by Damian Sosa in the meantime. This has been done just to because the document was so old that there were references to the experimental RFCs, which I mean makes sense to update it and put the right references there, which has been done between 1.11 and 9. Okay. As for the LispSec, the status is the following. I'm shepherding the document. So I already prepared the write-up, but because I had a few, I would say, small issues on the document, just to clarify things a little bit, I wrote my review, I sent it to the authors. As you know, Albert is the one holding the pen and making the changes usually and managing that. He is a little bit busy this period, so he was not able to make any progress on that side. So I recently contacted back Damian, which is willing to take the pen and try to solve the residual issues that are in the document. I will work with him to bring him to speed about the latest development. I hope that we are able to finish this document before Christmas. Okay. However, I invite all the co-authors to be a little bit responsive because any change that Damien does has to be validated by the other authors. Okay. As for the other documents, we have the Young model. I think this is quite ready, and after we unblock LispSec, this should be good to go as well and go for a last call. We have Lisp VPN and Lisp L2, L3 mobility, which will be discussed later on today. They are on the agenda. And then we have a bunch of working group items that so basically are working group documents that were sitting there for a while. And it's time to pay attention to them and review them. So what I suggest to everyone is to have a look to them and review them. We will go over each of one of them in order to see whether or not we want to publish them or not. Okay, because at the end, every publication is the product of the working group. So we have to agree to move it forward if there is interest in the document. And looking at the charter, there is one and only piece of work that is missing, is the NAT traversal document. Okay, but we have a good candidate that has been around for a while. So the Lisp NAT traversal. So this is something also to consider in order to make progress for 113. Okay. So as for the agenda, we have two working group items presentation. So as I said before, this is Lisp VPN and Lisp EID mobility. Okay. There is a presentation about a non-working group item, which is the map server reliable transport. And we will conclude with the Lisp fix. Okay. And this time we have enough time to discuss, so we shouldn't be short in time. So I invite everybody to ask question, clarification, just discuss. This is what we are for here. Why we have a virtual meeting this time, maybe a physical meeting next time. Let's see, let's hope. Okay, so anything, anybody has questions or remarks on the agenda or working group documents? Take it as a no. So the next three presentations are from Mark. Mark, you can share directly the slides yourself, in the sense that they have been uploaded on the Mitico. And if I stop sharing, you can ask to share. And
Oh, you're not sharing this time, or do you want me to?
I can if you wish, as you like.
Yeah, it's fine. Yeah, if you share, I can go.
Okay, let me choose. The first is EID mobility, as far as I remember. So this is one, is the first.
Thanks, Lucy. Yeah, this is Mark. Work at Cisco. Yeah, presenting three things today, but yeah, hopefully I'll take. Hopefully, I won't take too much time for them. Two of them, as Lucy was mentioning, are Lisp Mobility and Lisp VPNs. These two are working group items. We have been using them for quite a long time, and would like to recover the discussion around them and make some programs on these two documents. Okay? The first one is this one, EID mobility. So yeah, the title is L2, L3 EID mobility using a unified control plane. These
Mark,
are
may
the
I ask
authors. Go ahead.
questions? When you say
Yes.
we are using them for a while, means that it has been there is at least one implementation, and you are
Yes.
using it for
Yes.
the next
Okay.
two slides, or also for the third one, the reliable transport.
Actually, the three of them. Yeah,
Okay.
we use them a lot. Actually, yeah, we have. Yeah, to be honest, we have a lot of interest in these three apps because they constitute the basis of most of what we do these
Okay.
days. Okay.
Okay.
So yeah, starting with this one, if you can go to the next slide. Um, so these drafts essentially provides a list of methods for using a common control plane to concurrently support layer 3 overlays and layer 2 overlays, both with EID mobility. With respect to layer 3 overlays, the draft mostly focuses on mobility. I mean, it provides some forwarding descriptions, but the most important part is what to do with mobility. And with respect to layer 2 overlays, it goes over everything, right? The unicast and multi-destination, non-IP and IP inter-subnet. It also talks about how to optimize ARP and ND resolution using Lisp. Next slide, please. With respect to layer 3 overlays, what the document describes is that without mobility, what you need is basically already described in the RFC. But in addition to that, it gives some guidelines on how to support mobility with Lisp. As I was saying, right, the idea there with mobility is ETH register prefixes that are locally attached EIDs, or considers locally attached EIDs. Then it describes how to support traffic between sites. Again, here all the rules are already described in the RFC, but then it puts the focus on what to do when EIDs change location. And if you want, an important part here is how to update the network when these changes happen, right? And it proposes two methods. One is data-driven SMRs, and the other, or pops out map notifies. Okay. Next slide, please. So the next 3 slides try to illustrate this with a picture, what to do with L3 overlays and mobility. The picture starts with what we already know. Let's say we have multiple sites and we have 2 endpoints. Let's call it A and B. Endpoint A is connected to site A, endpoint B is connected to site B, and they are talking to each other, right? So essentially what we will have is the XTR on each one of the sites, register these locally connected prefixes. We used addresses 10111 and 10222. These 2 prefixes will be registered with the mapping system. And then when A is trying to send traffic to B, the XTR on site A will have resolved the map cache for B with the rlog of site B. Right? This is basically right, nothing new here. Next slide, please. And now we go and what happens when a prefix moves. So let's assume now here that B moves from site B to site C. Now site C, what will happen first is will detect the presence of this endpoint, and the XTR or the ETR on this side will now send a new registration to the mapping system, updating the rlog or the location of this node. Right? Now, what the document proposes or describes is that the mapping system must send a map notified to the old location, the previous ETR that registered this prefix. And when this XTR or ETR receives this map notify, it will create what the document calls an away entry. That it's basically a local registry that hosts or an EID that was locally present at the ETR. Now it's not there anymore. Right? This is what the document calls an away entry. At this point, the mobility detection has completed, but the problem that we have is that map caches or that have been stored all around other sites in the network are still stale. Next slide, please. And this slide talks about how do we update these stale map caches. The document proposes 2 basic options. I'll start with option 1. Option 1 is, okay, we have on this remote site, we have this stale map cache, so traffic is still being encapsulated to the old site. Traffic will be sent, for example, in this case, from XTR in site A to still ETR in site B. Now, when site B, the XTR receives this traffic, it will see that it's destined to NID that it's in the away entry. So as a reaction to this or to this discovery, what this site will do is send a data-driven SMR to the original site. Basically, this SMR is telling the other side, hey, you're sending traffic to the wrong location. And following this SMR, the original site will refresh its mapping entry, will start a map resolution process with the mapping system and find the new location of the host, right? Or the EID, and start encapsulation to the new location. This option 1, we call it data-driven SMR. The second option is take advantage of the procedures described in the PubSub draft, and whenever a site learns a map cache, also subscribes for it. So the mapping system will send a map notified as a publication, an update to all the sites that have this stale map cache. Okay. Next slide, please. So this was for layer 3, right? As we were saying, forwarding in layer 3 is all RFC. Mobility is what's different in this draft. When it comes to layer 2 overlays, the draft goes a bit more specific, and it talks about what needs to be registered, what it's all about, right? And it starts by saying, okay, EIDs in L2 overlays or MAC addresses, as you all know. But then what the document proposes is that in order to separate or keep layer 2 and L3 separate in the network, we dedicate a specific instance IDs for L2 and L3 purposes. Okay, so all the mappings for L2 and L3, or particularly for L2, will be IID scoped, right? And these mappings will be MAC to RLOC mappings. and the way we use instance IDs to segment the two types of overlays are all described in the VPN draft, right? That will come after this one. Then what the document goes is into talking about how do we do unicast traffic handling, BAM traffic handling, ARP and ND support, and mobility support. And the next slides go a little bit more on detail about these things. Next slide, please. So first, mobility. Mobility with L2, as described in the document, is no different from what we do with L3, right? So the idea is that in this case, MAGs are moving within a broadcast domain, or XTRs connected to common broadcast domain, but the concept of mobility is exactly the same, right? And the way we update map caches, it's also the same, data-driven based SMRs or PubSub. One specific note with respect to forwarding in L2 is that TTL handling changes from what we do in layer 3. So the idea is that even when traffic is crossing this L2 overlay, the TTL header of the inner packet should not change. Okay, next slide. In order to support broadcast and multicast traffic, all participants of an L2 overlay must join a common group, right? So that we can broadcast this information across all participants. The document reports two possible approaches to this when multicast underlay is supported. In that case, all participants must join a common group, this common underlay group, let's say, multicast group, and this multicast group will be associated to the particular instance ID that they are participating in. Okay? When multicast underlay is not available, then this document takes advantage of the signal-free multicast RFC and proposes that all the members register to a very specific group, right? Source 0 and the group is and group all ones, okay? And the same, right? Following the RFC, the map server and the participants will compile a list of all the participants that, so whenever there is traffic that needs to be broadcasted, it can be replicated to all of them. Next slide, please. There's one specific thing in L2 overlays is that normally ARP and ND traffic are represent a lot of traffic in the network. So one thing that we normally want to do is limit the amount of this traffic that floods the network. And this is something that we can also deal with Lisp. Okay, and in this particular sense, what the draft proposes is that we dedicate one instance ID to these mappings. The idea here is that XTRs can register with the mapping system pairs of IP addresses with consider the IDs to RLOCs, MAC addresses. So whenever an XTR wants to resolve one IP to MAC binding, instead of flooding the network, what it can do is just query the mapping system and try to gather this information from the mapping system. Okay. Next slide, please. This is still work in progress, but this was one of the last remaining items that we discussed in the group that was needed for the document. The idea is, how do we provide multi-homing services? One discussion that I'll open to the group is that we're having is whether this is something that we want to document in the draft, or we want to keep for a separate document. Okay, but yeah, let me talk about how we are approaching this. But again, we are still experimenting with this and seeing if this works. The proposal so far is that we use an ID to identify a segment that is multi-homed with multiple XTRs. Okay. And the idea here is that all XTRs that are part of this L2 multi-homing group register this segment ID with the mapping system with two specific flags, right? One, they always use the merge request bit, so that through merge semantics, the map server consolidates a list of RLOCs belonging to this group. And they also set the one map notify bit, right? So that all XTRs are notified with the RLOC list that the map server is compiling. With this, we achieve two things, right? For example, when we need it, right, and a designated forward that needs to be selected for this group, the map server can choose one out of the consolidated list, right? Instead of having to implement a distributed algorithm between XTRs to make sure that they all choose the same. For example, when we need to apply split horizon, the same, right? Based on these map notifiers, all XTRs know all the other participating XTRs, so they can apply it. They have the knowledge to apply this. Okay. Next slide, please. And finally, just one more, some other documents call it aliasing. We still need to decide if this name makes sense here, but the basic idea here is that when multiple XTRs are participating in one of these groups, they register EIDs with an additional attribute that is this segment ID. And then we use PubSub procedures as described in the draft, so that members of the group, they are all notified about EIDs that are detected by other members of that group, right? With these, all XTRs are able to learn the other EIDs, preemptively learn, let's say, all the other EIDs, add them to their local databases, and send a common MAC registration to the mapping system. One note or one question that we have with the group is whether you think that we should be using site ID for these, or creating a new segment ID tag to support this use case is the right way to go. Yeah, next slide. That's the last one. So open to questions here. As I was saying, right, we have been using this quite a lot. It's working, right, in practice.
Are there any questions? I have a couple just for clarification. So,
Yeah.
So you basically use the instance ID in order to distinguish between L3 and L2 overlays, basically, right?
Yes.
So, and but you do not reserve any specific value to the IID. I mean, it's just by configuration. Somewhere you say this value of IID is for L2. Is that?
Yes, exactly. So basically, at least how we support it is in configuration you go and you start defining instance IDs, and then you say, okay, you locally on the router, normally what you do is you bind an instance ID to a VRF or to a VLAN, right? And that's the way the router knows, right? Whether
Okay.
to link it to an L3 domain or an L2 domain. Yeah.
In what about Lisp GPE? Because we have the other header that could be used to um, yeah, to encapsulate, and you can
Yeah.
natively use different um, L2, L3, or other things inside, basically.
Yeah. I mean, the actually the draft has a section for encapsulation, and it documents, right, that you can combine these with Lisp GPE, and it fits, right? Actually, interestingly, also with VXLAN headers, right? And I mean, you need a header that it's able to encapsulate L2 and L3, right? And also segment, right? That's where the instance ID part comes into play.
Mhm. And just last two things is so it makes more sense to me, instead of defining a new segment ID, maybe to reuse the site ID in order
Okay.
but I mean, this is just personal opinion. I mean, and instead, as a chair, I have to say that you should revise the document, in the sense that I just skimmed through it, and it's based on the old RFCs. So
Oh, okay. Yeah.
6830, so it's good to update to the BIS document and make sure that is coherent with the set of documents that we have now.
Okay.
Uh, I didn't check, but maybe also because LispSec is mandatory to implement. Maybe think about what if there is any implication or whatsoever on that side on LispSec.
Okay.
Okay.
Okay. These are good points. Yeah. Yeah. To be honest, since the draft has not changed much, we haven't been paying enough attention to this, but I'll make sure that we update
Sure.
all this.
Sure.
Thank you.
Okay. So let me stop sharing this one, and we'll go to the other one that should be Lisp VPN. Here we go.
Okay. So unfortunately, Victor couldn't make it today. He was going to present this, but I'm taking over. I'll. This is the other draft that it's a working group item, and the same that we said before, right? This is extensively used in practice, and we'd like to bring back the discussion on these drafts and make sure that they move forward. um, Next slide, please. Okay, so the scope of this draft is all about segmentation, right? Segmentation in particular of the ID space, and it talks about how to use instance IDs and extended TIDs, right? Tuples of instance IDs and EIDs to segment our network, right? It goes into what are the implications of this for control plane procedures, how do we deal with this at the data plane and forwarding level, okay? And it addresses for both of them, unicast and multicast support, okay? The document also includes some considerations on segmenting the RLOC space. From the perspective of the document, most of the attention is on EID space. The segmentation of the RLOC space can be considered more as an opportunity, right, and how to deal with it. But the important part is the EID space. Next slide, please. The draft also provides some guidelines on, or well, some tries to address the methods to support cross VPN communications, or most commonly known extranets. And for extranets, it talks about how to deal with unicast and multicast traffic, and what are the implications when we do cross VPN for example, PubSub, SMR generation, RLOC probing. Okay. Now, the document proposes a particular encoding for home IIDs. This is relevant for extranets, right? And this is the encoding, right? A list with a first item that says this is the home IID, and the second item it's just the LCAF type 2 with the instance ID value. And you will see next, but the home ID is always encoded as an RLOC, as a proposal here. Okay. Next slide, please. Okay, the next slides try to go again a bit through packet flows here. I'll describe them very briefly, not to go too much into detail, but the basic idea when we want to provide segmentation is that we do IID scope registrations and resolutions, right? And yes, Luigi was saying, right? This, in some sense, applies also to what we were saying for L2 and L3, right? So the idea is that now we scope everything within the context of an instance ID. What do we mean by scoping? Is, for example, if we focus in the map registration, let's say that our network is organized so that we have a couple of instance IDs and we have endpoints associated to each one of these instance IDs. Right? Locally on each side, this instance ID can be translated to what we were saying, to a VRF, to a VLAN, or whatever we decide to associate it with. Right? The idea is, okay, now we have an endpoint, for example, in this picture, site B, we'll have an endpoint, let's call it endpoint B, that is associated to instance ID 1, and this site will register these with the mapping system using these extended EIDs, right? Extended EIDs is nothing else than registering as an EID the tuple instance ID plus the EID. And this will be registered with the associated RLOC of the site. Now, if we turn to map resolution side, the same, right? We make use of this instance ID. So let's say that endpoint A in instance ID 1 wants to talk to endpoint B in instance ID 1. So what it will do is when this traffic hits the XDR will also use this extended EID to express interest for that particular destination, right? And the same, extended EID in this case is instance ID 1 and the destination EID. Once map resolution completes, all this is stored also using the segmentation in forwarding, let's say, or in the cache. And again, right, using these tuples or instance IDs and EIDs, right? And this is the basis of the whole segmentation. No? When traffic is forwarded, we do the same, right? As we were talking before, on the header of the forwarding of the encapsulated packet, we will stamp the instance ID, so the egress node, the ETR, knows which segment this traffic is associated with. Okay. Next slide, please. Extranets work a little bit different here, but basically the idea is, okay, what if we want to allow traffic to cross segment boundaries? Okay. So the idea here is that, okay, it all starts extranets assuming that we have a policy in the network that says, okay, traffic from this instance ID can be leaked into this other instance ID. Okay? How this is structured following the document is that the ETR will always have this policy, right? And for example, using the example in the picture, we have a site B that, sorry, we have a site B that, for example, locally connected, it's only owning instance ID 3, okay? But it has a local policy saying, okay, you have to allow traffic from instance ID 1 and instance ID 2 to reach your destinations in instance ID 3. In order to do this, the XDR, what it will do is replicate the registration with extended EID, let's say 3V, but now in all other instances, right? So what it will do is replicate this registration with extended EIDs of all the target instance IDs that it wants to allow to communicate with this node. Okay? Something that is particular about this registration is that it carries the value of the destination instance ID, in this case 3, as an additional attribute of the registration, right? And this is what the draft calls as home IID. Okay? Now, if we turn to the sending side, let's say we have this endpoint A that wants to talk to endpoint B. The same traffic will hit the ITR on site A, but this traffic is coming in instance ID 1, right? So at that point, this XDR uses the VPN methods to resolve destination, and will send these map request, let's say, with the extended EID 1B, right? Because at this point, this ITR doesn't know that this is an extranet, right? As a reply to this map request, the mapping carries this home IID, right? And this is installed into the map cache. Okay? And this is the important part with respect to the extranets. Now, traffic will be encapsulated with the destination instance ID, right? So traffic sent on site 1, instance ID 1, will be encapsulated with instance ID 3, right? So that when site B receives this traffic, directly delivers to the endpoint in the appropriate VRF or VLAN, the appropriate segment. Okay. Okay. Next slide, please. And then, yeah, the draft also addresses how do we deal with extranets and multicast. It uses signal-free multicast for this, the same as before. In this case, everything more or less works the same, with one minor note is, well, not minor, but an important note is that, well, let me go through the flow and maybe can explain the difference at the end. So the same as before, right? If we start from the destination sites now what they will do is, they see some local node joining a particular group or expressing interest for a particular group, because they have this extranet policy. What they will do is register this interest in the multiple instance IDs that the policy is saying that they should replicate this registration. Okay, and this is what's happening in this graph, right? So receivers BNN are expressing interest in having traffic from source A to one particular group be delivered to them. Okay. Now, the important thing, or the important difference here, is that when site A in this picture tries to resolve the list of RLOCs that it needs to replicate to, it will receive this list that has been learned through signal-free procedures. Okay. Now, this reply also carries these home IIDs, but replicating to every destination instance ID would be a bit prohibitive in terms of cost, right? At the sending side. So in this case, what changes with multicast and extranets is that the source will still encapsulate with the source IID to destinations, and it will be the egress sites, the ETRs on the egress sites to decide to do this conversion between instance IDs, right? So they will receiving traffic from instance ID 1 in this case, and they will be the responsible to locally replicate to the corresponding instance IDs. Okay. Next slide, please. The same as before, the draft has not had many updates since it was adopted by the working group. In practice, it has been working for quite some time now. We've been using it in practical deployment. Yeah, most of the procedures here. And the only last addition that I could find with respect to the draft is that it included some considerations on how to calculate negative map replies when we are using extranets. Okay. And in order to include the home ID in these replies, but yeah, it's a minor note in the draft. The rest of the contents haven't changed too much. Next slide, please. And as we were saying, right? So VPNs really constitutes the basis for everything that we're doing these days for segmentation and extranet. And the solution has been out in the field. Code is stable. Yeah, it's been validated quite a bit, right? So the authors would like to request, if possible, right, the working group to make a last call for this document, since. And
okay.
I think that's the last one. Yeah. Mm-hmm.
No, there is comments. Yeah. We can leave this one. So before going to the last call question, are there any questions from the audience? I'll go ahead and jump start. Let me switch between slides. So here you say AFI is a distinguished name. And I looked to the document, it's a distinguished name type, but then it doesn't seem to be defined anywhere. It's just
17, right? I think, yes. Yeah, actually, that's a good point. I think we use 17, right, for distinguished names.
But this refers to the Dino's draft about distinguished names?
Yes.
But
yeah, I think Victor and Dino were debating how to provide this. Yeah.
Okay. If you're going to use distinguished names, then you're going to need to put in text about how they are distinguished, what keeps them separate. Because your example is just an arbitrary name. That seems to imply that they're going to collide in the mapping system. That's not good. But if you can keep them separate, then specify how.
Okay.
I will also start putting the document in the reference because it's not in the reference list. And again, update them because look, if you go here, you still have a reference to RFC 6833.
Oh, yeah.
So this is a general update that you need to do to all documents, I guess. I had another question here in the extranet. I mean, you show how it goes in one direction. I kind of understand how it will go also in the other direction. What if there is any mismatch? Do you discuss that? The sense that that by some reason you did not encode all the IIDs or something. This can happen when you do an update or something. You see,
yes.
Did you discuss that in the document?
I don't think the document discusses it, but it's a very good point because in practice, I mean, it's always a challenge.
I think the problem is similar to when you have several XTRs and then you want to update the mapping, it's just up to the, let's say, to the operator to make sure that you update all the XTRs at the same time in a certain way, so that the mapping is coherent. And you should know that if it's not the case, you have trouble. So you just need to add text that on that. I think.
Okay.
That,
Okay.
yeah. Joel.
I just went and looked at the draft. The use you're making of the name would make me very nervous. Please think very carefully about it. A, you're creating a dependence on a document that is not yet working group adopted. And B, what you actually say is that the name provides semantics. Names don't provide semantics. So be very careful about whether the name is really what you want for this.
Okay. Okay. Okay, yeah, I can talk to Victor and Dino and see if there's any alternative to this.
In light of these comments that we gave you,
yes.
I would suggest that we go first for a full revision of the document, and then we can certainly discuss our last call. I mean,
okay. Okay. Yeah,
okay.
I mean, I think the last call was more related to that there had not been too many changes,
yes.
right? But yeah, but it's a good point, right? Let's
we still have the bottleneck, LispSec, but and we need a revised version of this document because there is a couple of things to update and fix, I guess.
Okay.
Okay.
Yeah.
Okay. Unless there are other questions or comments, I will switch to your last presentation. This one. Here we go.
Okay. Yeah, the last presentation I promised I let others talk. The same, right? None of the others could be here today, but I'm presenting on their behalf. But again, this is we have vested interest in this draft, and you'll see, at the end I'll make another call to make it a working group document, and the reason we have this interest is because we have been using these in practice, and we've gotten a lot of benefits out of using these procedures here, and so I'll go through them, give some background on what we have been doing, and yeah, let's hope we can have a debate on this, or restart the debate on whether this should be part of the working group or not. Okay. Next slide, please. So just some background. The map server reliable transport is, as I was saying, extensively used in, let's say, our deployments, right? The reason we have this is because when we started experimenting with it, it showed very quick benefits to scale the Lisp deployments, and we consider that it's been key to support operation at scale for very large users, right? So this is true when we have, for example, a large number of VIDs, or when we have mobility, what we were describing in the first draft at large scale. And also, for example, when we try to plug Lisp systems with other systems and we need to do redistribution of database mappings, these also provide some stability at scale. Okay? In practical terms, since the draft proposes message reuse for many things, it was practically implemented as an extension of the registration process that it's well documented in the RFC. Okay. Next slide, please. So what's this document all about? Is this idea of moving from periodic registrations to using a reliable transport to support the registration process. So, well, as you always know, what we use originally, or what Liz uses by default, is this periodic UDP communication between the XDR and the map server and this is to maintain some soft state, right, between these two entities in the network. But yeah, when doing experimentation, especially at scale, we had there were some practical concerns on how to do this, right? And especially, yeah, when we are handling a large number of EID records, or when we have to do redistribution, mobility, and something that, for example, you can see very quickly is that this constant communication creates some load on the control plane. And for example, if you start attaching thousands of records to each XDR, this means a lot of traffic. And another area of concern was this lack of flow control, right, between when XDRs and map servers span multiple network hogs, and our network grows, right? So we wanted also to get some of these, right, in the interface. Next slide, please. So what's reliable transport? So what the document proposes is to establish a TCP or a SCTP, or to be honest, any session that it's considered reliable in some sense between the XDR and the map server, right? And then use this reliable session to communicate the ID to RLOC mappings, right? And also mapping notifications back from the map server to the XDR. The document proposes this always as an optional alternative to UDP-based registrations, right? And so UDP mechanism must be supported. This is not trying to replace anything, but it's always an alternative that can be used if available. Next slide, please. So the next slides try to put picture and how the operation proposed is meant to work, right? So the idea would be something like you have the ETR, the map server, and the ETR starts with the usual periodic UDP registration with the mapping system, okay? And this periodic UDP registration will continue as long as no reliable session is established, right? Let's say once reliable session is possible, let's say these two guys can establish a TCP session, then it's when reliable transport operation kicks in, right? Next slide, please. So once this happens, let's say now we have a TCP session available. What the map server will do is send a registration refresh message to the ETR, right? What this registration refresh message does is trigger the ETR to send a new refresh registration of everything that it has in its local database. But the important thing comes from here, right? From that instance, all these registrations are considered active as long as the session is up. So in some sense, we link the fate of the registrations to the state of this session between the map server and the ETR. And thanks to this, these registrations don't need to be resent periodically anymore. Next slide, please. Now, when we have this idea of sharing state between the two and linking the fate to the session, now we need some additional procedures on top of the registration process, and this is what the document it's all about, right? But the most important ones is one that now the map server can reject registrations and tell the ETR that it's rejecting registrations when it's not ready, or I don't know, let's say configurations or policy don't allow them, okay? And the registration refresh message is actually used as a way so that the map server can notify the ETR that, hey, things have changed. For example, now the policy that rejected your registration is not there anymore, and you can try again, right, to send me these registrations. This is one of the last additions that was made to the document, is that these registration refresh messages can be scoped, right? So the map server can specify, I would like you to refresh everything that you have, only what you have in this instance ID, or just send me this specific prefix that for some reason I lost state for it. Okay. Next slide, please. Yeah, from here, the rest of the slides is that what I described was the basic idea behind the draft, right? What the next slides go is just, okay, which are the specific details behind all these, right? For example, right, with respect to registrations, reliable registrations or messages are exactly the same as UDP registrations. So we do message reuse here. The only thing is that we package them into a TCP or reliable session packet. Okay. Because now the two entities are sharing state, right, and linking the state to the status of the session. Now the map server is given the possibility to give positive or negative acknowledgement to provide explicit feedback to the XDR. Okay. And what we were talking before, right? Now the map server has this ability to actively request for information to the XDR. One interesting thing is that if you think from a reliable transport perspective, mapping notifications are actually not needed anymore unless there's information to be conveyed from the map server to the XDR, right? For example, if we use merge semantics, mapping notifications would be needed, right? Or for example, for mobility, mapping notifications would still be needed. Next slide, please. Map server operation. Yeah, repeating more or less the same, but important things here is that now received registrations are used to create, update, or delete state. So there is no timeout anymore on the mapping system. As long as the session is up, the registrations stay. So on the other side, what this means is that the XDR needs to explicitly delete mappings to get them removed from the mapping system. Another interesting thing that the document proposes is that registration state is not discarded when the session goes down. So basically, if let's say the session goes down, what the map server does is fall back into timer-based mode of operation. So all the registrations it activates a timer to let them expire as they would in a UDP model. Okay. And well, these as usual, right, registrations can be rejected for a number of reasons, but mostly is either authentication or policy of configuration limitations, right? And what we described in the flow, right? The registration refresh message is basically used is a tool that the map server now has to obtain initial state or request specific registrations when something changes in its configuration, its policy, its status. Right? Okay, next slide, please. From an ETR operation perspective, okay, the document provides a detailed state machine and transitions between states, but the important thing to remark here is that what we have been repeating, right? The idea is the ETR starts in UDP registration mode. Now, if a session is possible, the ETR will try to switch to reliable transport mode, but this won't complete until the map server sends this registration refresh. Right? That's the key element in this whole process, that where both the ETR and the map server know that now they share state and they have linked the fate of this state to the status of the session. Next slide, please. So implementation nodes, as we were saying, right? We have vested interest in this because we've had code running and very stable for a long time, and it has been very, very effective to support large deployments. One important implementation node is that since we reuse messaging, all this was implemented as a, let's call it minor extension to the registration process, right? So that it could run over TCP. Okay? And as I was saying before, right, this doesn't need to be linked to TCP, HTTP, right? It can use any transport that we can consider reliable, right? At some point in the working group, we were talking about using Quick for this. That's always a possibility. One thing doesn't collide with the other. Next slide, please. And yeah, our usual call with respect to this draft, we would like to request adoption for this document in the working group. Yeah, and that's the last one. Yeah. Questions, remarks.
Okay, before going to this question, let's see if there are any questions from the room. I would go for a no, but there are two small questions. Yeah, you say we always start a registration with UDP, and then when there is a session up, then I switch to the other. Now,
yes.
To me, it's not clear how we understand that we can set up a session. Is there an explicit signaling, or is just by configuration and we wait that it comes up?
So what we do, and now we are talking about our implementation, I guess we could all do different, but what we do today is we use we send the ETR will send the map register. We'll set the one map notify. Okay, when it receives the map notify, it understands that it can try to establish a TCP session, right? It understands that, okay, I've been, because the map registration is authenticated, okay, I've been authenticated with the map server, right? It's allowing me to do stuff. So at that point, it tries, right? And the way we have implemented this is back-off mechanism, right? So if the map server doesn't support TCP, then okay, fine.
Okay, it's a try and fail in the sense that I send up a first message. I see on the other side there is someone answering and is somehow authenticated. So I try to speak TCP or STP, or as you say, I try quick. And if it doesn't work, I just continue
with UDP.
With UDP. I mean, you can add text in the document saying you can try with this system a simple policy, more complex policy, or say, or this by configuration. Other methods are out of the scope of this document. At least you have a basic thing that says how you go from one to the other. I mean, because otherwise it remains to me a little bit fuzzy, because if I read the document and I say, oh, you can go from this to that, and I have to implement it, I will scratch my head and say, yes, but what is the signal that tells me when I should go on the other side? You see what I mean?
Yes, that's a good point. Okay. Okay. That's a good suggestion.
Another personal observation is the fact that you authenticate the nodes using UDP, but you don't have a security layer. And now, as a chair, I would say that we had a lot of issues about security with the main specifications. If we move this document forward, chances are that security review will come back to us and say this system is not secure. So I would suggest to look at how LispSec applies or to this system, or you say, I don't know, you set up a session and I put up TLS, or in Quick you use the Quick security. I don't know, but just authenticating the other side, I fear that is not enough. Then obviously other people can have a different opinion, but and sorry, go ahead.
No, it's a good point. I'm not sure if the draft now has a section. I haven't.
There is a security consideration, but it's only about authentication of the other side, and you use basically TCP authentication or STP options. There is not that much, so I would encourage to go further on that.
Yes.
Also, the references, I guess, that are stale. And
actually, I think this one has expired. So I think this one has expired.
I was coming to this point. I mean, you know that the answer to the request for adoption cannot be issued if the draft is expired. We cannot adopt an expired draft.
I
more seriously
today.
I mean, so there are few updates that you can do to this document again. On a personal side, no chairhead. I like the document because I think that with a reliable transport, you can do a few interesting things on the map registration and on the mapping system, basically. So I like the work, basically. As a chair, I told you my concerns, and I think the draft should be revised, and I don't know if it's clear, but the priority is LispSec. So because the co-authors of this set of documents overlap with the authors of LispSec, you can deliver the message that as soon as we are done with one, we can move the others. So
put some pressure then,
I mean, it's fair enough. I mean, we put a lot of energy, and this is just the last piece that is missing, and we'll unblock a few things and give a lot of work to Alvaro. But anyway, this is how it works. Okay. Any other comments from the audience? I guess that's not. So thank you very much, Mark, for all these updates. And we will move to Sharon. Sharon, I will share your slide if that is fine for you. We can continue this way.
Thank you, Luigi.
See the slides?
Yes, I see. I will gently. Thank you. I will gently present with Aviv Yecheskel. We're presenting here LispFix. This is a second example of using the existing Lisp RFCs and mechanism established for a use. The use is for compute-first aggregation of large amounts of data that has to be quickly propagated based on change, an exception, or an anomaly. So unlike the Hexagon RFC, which is a draft, which is also like that, which is in production and in publication, here we just prototype this thing, and we are gathering inputs for draft 00. Also, it's interesting to note that this use of Lisp for data aggregation and selective propagation is like the opposite of CDN, in a sense that there's a lot more data production than consumption. It's push versus pull, and DNS indirection is less applicable because of cache coherency or latency aspects. Okay. Another pre-note is that the qualities of using Lisp, the formal specification, the breadth of the RFCs, the multi-vendor interoperability, are becoming clearer to stakeholders in each domain, for example, in vehicles or in cyber, as time goes by. They see how this basis has more benefits than initially was anticipated. So specifically for IPFix, so this proposal has to do with a change in the traditional role of IPFix. If we thought of IPFix in the past as some kind of built-in Wireshark to log and debug the network, it's now becoming a critical sampling tool for networks. So uniform sampling with AI outperforms probing with AI, which outperforms probing using traditional rule-based systems. So we know that now, based on research. This is a domain which Aviv is expert on, so I will let him explain in more depth why is that the case. And of course, sampling is a lot simpler to deploy than probing, putting something in line or pushing agents to various points in the network. So sampling is outperforms, and it's much easier than anything else. But the catch here is uniform sampling. So uniform sampling of small sites like a hospital, school district is very easy. You just IPFix the firewall and a core switch. But uniform sampling of large virtualized environments is difficult, and Lisp can solve that. So next slide, please. Okay, so I will hand it over to Aviv. Yes.
Thank you, Sharon. Thank you for the intro. Hello, everyone. So, as Sharon described just now, the advances in network sampling over the last years is incredible. I did my PhD, researched this specific problem, how to infer from 1% about the 100%, developed some rigorous mathematical theory about it. And we see more and more companies in this field today, in the sampling field. Specifically, the combination of sampling and AI opens many possibilities for not only efficient, but very accurate network monitoring and threats prediction in scale in any application. As an example, take a look at the AI architecture you see in this slide, the autoencoder architecture you see here. Let me describe this data flow going from left to right. So it's basically 4 steps. The first step is network samples, just usual network samples arrived in our autoencoder. The next step, the second step, is that the autoencoder tries to reconstruct what is the expected input, and it outputs some loss because it's not a perfect reconstruction, of course. And the loss is the deviation between what was the input sample and what was the autoencoder reconstruction, very similarly to EKG signals. The third step is that the loss is normalized to one single statistical distribution across all different client networks. This is the key here, the normalization. And why it's so important? Because in the last step, in step number 4, the normalized loss of each and every client is forwarded into one single global network anomaly detector that's doing pattern matching against known threats in the normalized way. So this approach that you see here, this example of losses normalization with small network samples, when compared to full network probes analysis, it found out that this approach, the sampling with normalization, is significantly outperforming the probe of the 100% of the network. Not only in terms of performance, but also in terms of its accuracy. You can see in the table below the F1 score, which combines the recall and the precision together, the true positive, false positive together. And you can see a comparison in column 3 denotes probes solution, and column 5 denotes this sampling and normalization. And also in the false positive, which is under the recall, the second row, much better results. So not only in lab simulations, this approach that you see here is currently deployed in hundreds of network sites with radically different network environments in volumes, sizes, and architectures. However, in all of these deployments, in order to do the uniform sampling, we can do it very simply. We just need to activate the standard IP fix in one core switch, one firewall, because the sites are very small. But when we go to a bigger virtualized multi-tenant environments, we need a better way to aggregate the standard IP fix in order to achieve this uniform sampling.
Okay,
next,
so next slide. All right, so we understood sampling is good, and we take a look at virtualized cloud native environments in which any process can run on any Kubernetes cluster on any server. The network facilitates that by having lots of links between any rack to any rack. Probing is really not an option. These links are very high speed, and probing all of them is just impossible. Resorting to agents increases the attack surface significantly, and in each server, right in the soft belly of the OS, so that can and has been used to compromise cloud environments. So what do we do? So next slide. So if probing is not an option, server agents increases complexity and attack surface, and the default IPFix collectors on the switches will not result in uniform sampling of any of the apps running on the data center environment. We would like to introduce a Lisp specification that will solve that. So next slide, please. All right, so what we suggest as a specification for exporters, IPFix exporters, and also collectors as an interim step, is the ability to steer traffic to EID collectors which are logical and will result in uniform sampling based on a specification of group membership which is efficient in space, meaning a sample gathered in the exporter would be matched to a group member test, like a Bloom filter or a regular expression, or algorithmically to an EID based on the headers as deep as we specify in the sample, and therefore will steer the sampling to analyzers which are per application, resulting in uniform sampling per app distributed in the data center using an overlay which is built into the center. The network aggregation itself, the IPFix aggregation, can be provided by the infrastructure provider, and the EIDs will hide the equipment from the sampling analyzers. The sampling analyzer can be a cyber provider that provides a service to detect anomalies for the application. The anomalies can be preparation for ransomware, trying to disrupt, and trying to leak information under something which looks like a kosher exchange. All right, so this is the ask. Appreciate any feedback. I know it's hard to give any feedback in these online sessions, but offline are very welcome, and towards specifying a 0-0 draft of this. Next slide. Okay, here we just summarized sampling is good. Sampling in virtualized environment is hard. Uniform sampling, Lisp can fix that. Okay. Any questions? Yes.
Padma, go ahead.
Hi, can you hear me?
Yes.
Yes.
All right, thank you. Hey, that's a very interesting study here. I wanted to ask you a question about as you're actually making those samplings, and I can see that you're actually talking about reduction of how much of sampling is done. However, I wanted to ask something about the priority of the packets. Those sampling, are these seen as control packets or are those seen as regular packet for the apps?
Yes.
That's a good question.
So this is using the standard sampling protocols, and IPFix is the IETF standard, and there are also the NetFlow of Cisco and SFlow standards as well. We get 1 out of X packets, either as a full packet without its payload, or summarized by the connections, by the flow themselves. So we're discussing about usual IP headers, either as a full details IP header or summarized per connections. Is this answering your question?
Kind of. I'll follow up offline with you. I had a couple of questions about, the competition between that amount of sampling as control traffic and how would that work. But I'll follow up with you offline on that one.
Okay, I think the question is after the sampling has been gathered per application, the sampling records, are they high priority traffic just to protect the process of ongoing sampling? So analysis will be protected, and I think we can answer that online, and that's a great point.
Oh, thank you.
Yes, of course.
Mark, you disappeared from the queue. No more question. Please go ahead.
Yeah, no, I think, yeah, this is a bit more specific. I don't know if you guys solve it later, but could you give an insight of how are you structuring the EIDs, or how do you see EIDs being structured to support this?
But that's a great question. So currently, it's a private space of cyber CFN network, but that's it relates to your presentation also, Mark. And there's about space conservation. Do we match a specific EID to any group testing, or do we simply algorithmically generate EIDs and use the mapping system for longest match, for the best collector for this? These are good questions. Okay.
Okay. Yeah. And just trying to map, to comfort zone for even what we work on. But yeah, I'll wait for document.
Yes, that is a
Thank
great.
you.
Thank you. Okay, if there's no more, we can move to the next topic. Okay, so this is more mature. This is in production and currently in deployment. The Lisp Hexagon in thousands of drivers in New York City, and also now by industry consortium in Tokyo. that's been under construction right now. Servers have been allocated, but the other cities in the US, it's full production. I'd just like to give a quick brief learnings of what we see and what the stakeholders in the industry see from using Lisp for this mobility in terms of vehicles use cases. Next slide, please. All right. So what we achieved using Lisp is really take the full spectrum of mobility networks, which were very split between vehicle to vehicle, which are based on geospatial networks, like in IP-Wave or DSRC, for stuff which is immediate and very transient, versus vehicle to cloud, which is like you drive for a couple of hours and then you upload overnight what you collected, and then the cloud crunches fresher maps. So using the hierarchy and the layering, we are able to unify using one architecture all these use cases, and also all the use cases of stuff that fell in between. So what you see here is an example of using the hierarchy and layering for detecting parking, which is something that has to be done quickly, and previously had no answer in V2V or V2 Cloud. Also, understanding the cycle of traffic lights, or doing some kind of patterns on the curb activity in an area. So all these things fell between, and really the use case transience is really determined by the mobile network. How much do we have in terms of capacity? What is the density, and what is the latency? This layering works when, let's say, Toyota wants to find parking for its customers, its drivers, based on its cars. So there are some cars of some Toyota cars are finding parking for other Toyota cars using EAD abstraction of the geolocation provided by Toyota. But it also works when, let's say, Toyota and Subaru have an agreement to jointly collect uploads using an H3 EID, and then have agreements with Parkopedia or Bosch parking services using other H3 EID, same H3 64 bits, different EID. And then Parkopedia has an agreement with the city. Not only, it detects parking for drivers, but it detects permit violations in construction for the city. So this is, again, using the same mechanism, the same RFC, and people are seeing that this basis is good to build on. So next slide, please. All right, so as we described, the key for unifying the use cases in one architecture is by abstracting the geospatial network into geospatial EIDs. It's virtualized instead of physical network. And these geolocation services, they utilize areas based on uploads. But that introduces key issues to the industry, which Lisp answers in a very elegant manner. One is, since we associate vehicles to geolocation services not randomly load balanced, but based on where they are, then depending on how much traffic there is, you need to dynamically set the resources, and you have to do it transparently to the vehicles because that's a mass market. So by using EIDs, we can do that. We can switch geolocation service from one server to a server with 10 of those to a server with only 2 of those, and that's solved by using EID. The second key issue, which as a result of this abstraction geospatial abstraction is geoprivacy. It's unlikely that because I'm using a parking service, the parking provider knows where exactly I am every point of the day. So again, here the EID layering solves that. The network is aware of EIDs, the geolocation services are aware of EIDs, but the EIDs of vehicles are ephemeral and changing, and these are not IP addresses. So I have IP geoprivacy. Also, because I'm driving between geolocation areas, I'm switching context to where is it that I'm subscribed to or upload to. And that has to be seamless, cannot be done via DNS. It takes too long. And again, using EIDs, H3 EIDs here solves the problem. And the fourth item is while I'm driving, my reception may change between AT&T and Verizon or KDDI and NTT, but I must maintain my identity for the subscription to hold. Therefore, I'm not using IPs because IPs will change. I'm using EIDs. So these are things that the industry begins to see. Begins to see that it's good that it's specified as a standard, as a multi-vendor standard, and can be leveraged in multiple tiers of the application. Last slide. All right, so what we see is that using this specification and use of Lisp, we're able to scale, crowd scale, actually processing of uploads. We are able to propagate information based on change or exception or anomaly using signal-free propagation. And we are able to facilitate latency because we pre-select our logs for H3 IDs to places where the latency from the IP anchors is known and controlled. So why is this important? It's important because human reaction is a long latency, so that's not the point. The point is more when a car is driving in 20 meters per second, if my latency is high, I'm missing a lot of meters, and therefore I can pre-select the RLOCs and then move the geolocation services, the H3 EID geolocation services, based on a load of traffic. So that's it. That's the update. It's in publication. I wonder if we can get some kind of indication on when the RFC is going to be published. It's very hard for industry outside the IETF to work with any kind of draft, so it will be good to know. That's it.
Thank you. Yeah. Are there any questions from the audience? I have a simple one. These are two interesting use cases for Lisp. The question is, in order to solve these use cases, do you think that there will be any modification or extension to the Lisp protocol per se? Or
I think
yeah.
So it may be, but so far not. So far the specifications give enough flexibility. I mean, sometimes you have to think what exactly am I using and how before. How do I allocate EID as was asked before, and how do I what meaning do I give to things, and how do I use signal free to partition themes and subscriptions, and what does it mean for replication, which XTRs to use, a vSwitch or a full-blown hardware that can handle like cities. But so far the specification itself has been good enough.
Okay. Okay. Any other question from the audience? Mark, please go ahead.
So in practice, with signal free and replication, have you seen any scalability issues when deploying these? And I don't know if you have to replicate to many sites.
So yeah, that's a good point. Great point. So actually, for these networks where there's a lot of production of data routed to somewhere close for reduction and then propagation based on subscription, usually it's a lot of channels of very few subscribers. So signal free is really good for that.
Oh, okay. And I think in the last slide you talked. Can you go just one slide back, Luigi? Just.
Here?
Yes. So these pre-allocation of RLOCs, are you doing priority here, or are you just doing a selection of? So you have a list compiled from signal free registration, right? And then you get all these RLOCs in a list, and then what you do is filter them down.
Okay, so here's the situation on the ground is like we get a few RLOCs for H3 services, let's say from the Oracle Cloud, from Wavelength, and we know they all meet the requirements of latency between them and the mobile carrier IP anchors. Okay.
Okay.
But it doesn't relate to where the car is, because even though the car is moving, as far as IP anchor is not moving. It's mostly related to, I know that if I put an H3 EAD service there, then the car can upload more data per meter. So I'll have more coverage. I can get more out of any car.
Mm-hmm.
So now I have to put the EIDs on the RLOCs based on load of current commute situation and move it up. But I know the SLA of utilization of per car ahead of putting an EID service there.
Oh, I see. I understand now. Okay. Yeah, I had gotten a bit confused. I see. Thank you.
Any other question? Okay, so thank you very much, Sharon. So this brings us at the end of the presentation that we had in the agenda. At this point, the mic is open for any question or anything people want to discuss related to Lisp, obviously. Okay. Seems that everybody's more interested in starting the weekend rather than discuss with me. Okay, folks, thank you very much. I think that this brings us to the end of this meeting.
Thank you all.
And see you again in 113. Bye-bye.
Okay. Bye-bye.